Tihe moriora, ena mana, ena reo, ena karangatanga maha, tēnā koutou. Ea kūrangatira, kia tātou e tone kanui taku mihi. Ta huti mai ki te tātou hui whakanui. Ka nui te honori ki te mihi kia koutou, nō reira, tēnā koutou, tēnā koutou, tēnā tātou katoa. A very warm welcome to family, to distinguished guests, to colleagues, to students, and to our broader public, to the inaugural lecture of Professor of Artificial Intelligence, Bing Xue, from the School of Engineering and Computer Science. I'm Jennifer Windsor, Acting Vice-Chancellor of Te Herenga Waka, Victoria, University of Wellington, and it's a really great pleasure to see all of you this evening and to recognise the work of someone who has been an extraordinarily impactful member of our university community for over a decade. Professor Xue is a world-leading expert in artificial intelligence. She first joined our university as a PhD student in 2010 and received her PhD in 2013-2014. She was named a professor in 2021. Now, what's immediately obvious from this time frame is that Bing has moved through our academic ranks to professor unusually and extraordinarily quickly. And while it's very tempting to make much of the time frame itself, it's the underlying importance, innovation, and generative nature of her career to which I'd like to draw most attention here. With her colleagues and broader research group, Bing has packed a great deal into this time, and she's made superb contributions and been a great influencer across research, teaching, engagement, and in her leadership. She achieved our Early Career Research Excellence Award in 2017 and the Research Excellence Award in 2019. She's supervised over 50 students and is known to be deeply invested in the academic journeys of each of them. Indeed, she was awarded the Faculty of Engineering Supervisor of the Year Award in 2018. I believe that Professor Xue is also now Deputy Head of School, and she will lead the new Artificial Intelligence major in 2023. She's also part of a group of people in the Faculty of Engineering supporting female and gender diverse students, and she chairs the Women in Engineering Affinity Group for a New Zealand chapter of the Institute of Electrical and Electronics Engineers. She is the first woman to be named professor in our Faculty of Engineering. Artificial intelligence, AI, machine-based learning of data, AI can have significant benefits in its relative speed, efficiency, user access that humans can't quite do yet. And so in its ability to solve very complex data problems, it has some immediate and important applicability to a whole wide range of real-world problem spaces, whether that's biology, medicine, aquaculture, transportation, entertainment, you name it. This is work of the future as well as work of the now. And much of Bing's work, for which she secured over $20 million in funding, is in the basics. It's in data mining, feature selection, classification and image analysis, swarm intelligence, and evolutionary computation. The idea of computer programs continually evolving or improving from an originally random group of programs. I'm going to give just one example of the impact of Bing's research program. Her work on AI algorithms to detect skin cancer from images has been cited all around the world, and it could provide a future early detection method for skin cancer. So what Bing does in this basic science approach, I would argue, is potent, exhilarating, and aspirational. And in her inaugural, Bing will discuss the AI work she and colleagues are doing that very well may help us all shape a sustainable and an equitable future for us all. Aspirational indeed, and perhaps who better to help lead us? Kia ora rawa atu, Bing. Many congratulations and thank you. It is my great pleasure to introduce Professor Bing Xue and invite her to the podium.
Thanks, Jennifer. Tina koto, tina koto, tina koto kotoa. Thanks, everyone, for coming to my inaugural lecture, especially in this very cold weather condition. So I'm professor of artificial intelligence. Many of you know me, or you can probably tell I'm from China. And China has the largest population in the world, and my province has the largest population in China. But this map is not about the population. But some of you probably can guess. So this map is actually about how difficult to enter the university in China. So the difficulty of the university entry exam. Myself, unfortunately, but probably not unexpected, as I had to take my university entry exam in the central China, in this here, the province with the black color. Our province this year has 1.25 million students take the university entry exam. That's where I did my undergraduate. And then I moved down to the south, to another province with a black color, doing my master's study. So over the years, I have been very lucky, I had to say, with a difficult time when I was very young, so prepared me very well for the future of my career. Then we talk about artificial intelligence. We often talk about artificial intelligence, so AI it's everywhere, it's not only one thing, so it's a multidisciplinary area. And whole of my academic career, from my undergraduate to my master study, I found out that actually I have always been in the multidisciplinary areas. When I did my undergraduate, I was doing the major information management and information system. That is a major that you may find it in a different school at different universities. Some university had it in the School of Business, School of Management, and School of Information Science, or School of Computer Science. I think I was very lucky I was together with the School of Computer Science. I will be able to learn a lot of computer science courses in my undergraduate. Then I moved to a master's study, and the corresponding master degree there in China was management science and engineering. I did that in Shenzhen University in China, was very south in China next to Hong Kong. And I did that in the management school. And as my university, so there was I was doing the science version of management science and engineering. There is an engineering version of management science and engineering. So I go study a lot of engineering courses during my master's study. And a group of supervisors in our school, in the management school, was passionate with computer science. They love pattern recognition, distributed computing at that time. So I got to learn courses from computer science in the master level. However, I also have learned many different courses. And also statistics, operational research, mathematics, even economics, accounting, marketing, all of this. I feel like I know a lot of things. I also feel like I know nothing. I don't know where my career is going to be. At some point of my master's study, I actually enrolled a test to do CPA. I thought I probably can work as an accountant. Then after that, I changed my mind because we do finance courses. I thought I probably can do CFA, so that gave me more pay at least. Until I go with my friend, take a course called Data Mining and Machine Learning. I was amazed how those algorithms can discover the patterns from the data that I never thought about. How they classify or group data into different classes, and how they visualize the data. Until now, I feel like now I found my passion. So I did my master thesis, kind of using artificial intelligence algorithms. Then I decided to have a career in artificial intelligence. I applied to study overseas, and I was lucky enough in 2010, I got a scholarship from University of Wellington, from my university now, and I study here. I feel like I start working in artificial intelligence, that kind of opened a door to a new world. I feel passionate about everything I do in this area. And I submitted my thesis in end of 2013. As Jennifer said, I graduated around 2013 or 2014-ish, and has always been with VUW since 2010. So I did my postdoc, I did my lecture, and senior lecturer, associate professor, and now I'm a full professor, and that's why I'm giving this lecture here. So with my career path, so the most question I got is people saying, do you sleep? I didn't got that today from Jennifer again. And yes, so there's many times my husband would say, you're crazy, right? Whenever he wake up during the night with 2 o'clock, maybe 3 o'clock, I'm still working. He become very angry about it. But I feel like there's more things, because I really love the research I did. But the longer time I stay here at this university, with more roles, so I become a supervisor, I'm the lecturer, I'm teaching, and then program director, and also deputy head of school. I feel like I'm so lucky to choose a career that I love all the things I'm doing. But of course, there are many other stuff. With your career progress, you have a lot of other stuff. You have those tasks, responsibilities, and meetings. You see that all the professors' calendar, you hardly find any space in their calendar to book a meeting. So how many people asking that how you manage that? I use one of the important terms, one of the important techniques in artificial intelligence. It's very important, I call it multitask. I do many things at the same time. So I will touch that point later as well. So that's what I at university. Outside the university, in the international community, so it's actually only the past, let's say, 6-7 years, or 5-6 years. I have been working in many different areas. So from the conference, international conferences as a PC member, and now these days I'm becoming a general chair or invited the general chair or conference chairs. So one of the major conferences actually we hosted here in 2019, the IEEE Congress on Evolutionary Computation. So that was the largest conference in the evolutionary computation research area, and has never been hosted in New Zealand. So we beat the conference, and it was become a very successful conference in the IEEE Computer Intelligence Society history. And Professor Margaret Helen gave us a speech in the conference dinner. For that conference, I will be a conference chair for 2024. That has been already decided last year. And for journals, when you become some stage of when your publication, your research get noticed by others, and you will be invited to be associate editors. So I become the associate editors of nearly 10 journals, including almost all the top journals in my field. And early this year, I was invited to consider to be editor-in-chief of one of the IEEE transaction journals. And for the first time, I said, no, sorry, I need some sleep. And also, I feel like I have many students here at the university, and at some point, you have to prioritize what you do. And then international committees, and for chairs, and also international talks. At the beginning, you give paper presentation in international conferences. And this year, in recent years, I started being invited to give keynotes, to give tutorials, and also this year, I was invited by IEEE Congress, World Congress on Computer Intelligence. That's the conference normally have 2,000 people, over 2,000 people. It's a combination of 3 big conferences in evolution computation, in fuzzy systems, and neural networks. So I just gave the plenary talk in July, so just 2 weeks ago. So I was particularly proud of this plenary talk because in 2010, so one of the plenary talk was given by a Turing Award winner. The Turing Award winner is like the Nobel Prize in artificial intelligence. It's the highest recognition award in the computing. And there's a lot of other work that has been doing for example, Women in Computer Intelligence Society have been helping many women students or female early career researchers for developing their careers as well. So I'm passionate with doing that. I'm still doing that for many years. So with all my research, and there's another award that I just announced. So I was awarded the 2023 IEEE Computer Intelligence Society Outstanding Early Career Award. So I mentioned this award because it's super, super difficult to get this award. So that's again across 3 areas in IEEE computing intelligence. And people were saying this is even harder than a Pioneer Award. Because the Pioneer Award for the 3 areas, you got 3 awards, 3 persons got it every year, and this one you got only 1 person. It has a very high standards. In some years, no one got it. So I will receive this award next year in one of the conferences. So now talk about myself. Let's talk about more about artificial intelligence. So I'm not sure how many of you have watched this movie before. Great. So this is a movie that's released in 2001, directed by Steven Spielberg. So that's a very famous director. So this is a very good movie. So it tells a few very beautiful but sad stories about artificial intelligence, about robots, and humanoid robots. But in particular, this little boy in the middle, he has a very sad story. He was adopted by a family, but then later on was abandoned by the family because the real boy in the family kind of guided these robots to doing something considered being dangerous to human. But this boy is actually, robot is a very kind person, kind of personality. He got emotions when he's staying with the family. And it was a really good story, and a lot of things we still should think about it from this movie. So actually there was one thing, we think about whether is AI being dangerous or is a human being dangerous. And there's one thing, actually, I did not believe is true. I do not believe the artificial intelligence and robots can have emotions. I still do not believe. But this movie, kind of at that time, made me believe one thing: artificial intelligence is all about robots. But that was 21 years ago. But still, then many people at this day still have this misconception. If you Google artificial intelligence from Google Images, you find many images will have robots there. But we often say artificial intelligence is not about robots, not only about robots, it's a lot many other things. And then come to 2015, 2016. Okay, now many people knows artificial intelligence from this AlphaGo, from the Go challenge match. And from this news, and many people start thinking, artificial intelligence, deep learning. Okay, so artificial intelligence equals to deep learning. Or people know a bit more of artificial intelligence, they will say, oh, actually, artificial intelligence equals to machine learning, and machine learning including deep learning. Even more, and people will say, actually, that deep learning is deep neural networks. So then you see artificial intelligence equals machine learning, equals deep learning, equals deep neural networks. Well, it's not true, right? Many of us know it's not true. So artificial intelligence is a lot more than just machine learning and than just deep learning. So if we define, so what is artificial intelligence? I had to say there's no agreed definition. You can define artificial intelligence from many different point of views. So some of the key points in terms of think, sense, or act. So that involves like humans, that think or act like humans, or think and act intelligently. As a group together, based on the early definitions from the father of AI, John McCarthy, so our AI group come up with this following definition. So artificial intelligence is a science and engineering of making intelligent machines that can sense, act, learn from experience to perform tasks for humans. So the first half of this definition is not we created, it's actually we inherited from the very early definition. We particularly like the science and engineering of making intelligent machines. That's justified very well that we're offering artificial intelligence degrees at the science degree and in the engineering faculty here. So if we define artificial intelligence, still, these days, if you're talking about the most advanced techniques in artificial intelligence, unfortunately, it's still deep learning, and still a lot about deep neural networks. Whenever you got a very difficult tasks, if you don't know what technique to try, okay, try deep learning, try deep neural networks. So you can even dream even bigger. Right? This is the beginning I talk about the multitask learning in artificial intelligence. So the lead of Google AI, so Jeff Dean, who proposed an idea last year in October 2021, he talked about a pathway, a new large-scale multitask learning architecture. The idea is to build a single model that can generalize across millions of tasks. You can generalize as many tasks as you want, but bring a single model. And then in May this year, just 2 or 3 months ago, their work was published. They're using an evolutionary approach to build this large-scale multitask learning system. They will be able to address simultaneously 68 image classification tasks and achieved state-of-the-art results on each of them. The task that they considered, including the most very, very difficult tasks, for example, the ImageNet C510 or C500. Each of them is considered as a difficult task in many of the research. So that's amazing results. So using the evolutionary approach, which Victoria University of Wellington, so we have a world-leading research group in evolutionary computation. We're also doing the research on evolution computation for the automatic design of deep neural network architectures. but we're not even close to this point. Well, the thing is, when we're looking at, you probably say that you haven't heard about this system. Well, actually, after this system was published, after the paper was published, many people were not happy with it. The reason is, look at how much resources they needed. For a single run, it needs 17,810 TPU hours. That equals to 57,000 US dollars. Okay, I was counting my fundings. I had a master. That's a master I got $700,000 New Zealand dollars. That I need to pass 2 rounds of the proposals. And for computer science, for ICT, the passing rate is about 5%. And the whole master found I would be able to run 7.57 runs for his single system. But wait, it's even worse. Because before I will be able to run this system, I will need to do probably hundreds or probably 1,000 times of parameter tuning for the architecture. If I count in all the fundings I have in the research group or probably in the school, in the faculty, I still wouldn't be able to get this point until I retire. So that's why many people in the internet would discuss that we don't believe on the research they did by these top institutions. And that comes to another point about artificial intelligence recent years. People were saying, so the advances about artificial intelligence is more about hardware. Right? You do a lot of resources, you do a lot of things, then you can get a good results. As one of the researchers who work at the university or institution who do not have 10,000s of computation resources, I was not happy with them as well. But now it feels like I suddenly found a different way to think about it. I think it positively. Those research tell us what is possible. They use a lot of resources. Now our task is to find a way to reduce the computational cost. I suddenly feel it gave me a great idea for my next master proposal. See, this is what's possible, and I'm going to reduce the computational cost. So actually, that leads to some of the research we're currently doing. So we're doing the automated design of the deep learning models. So this is a topic we have been working on that for several years. So the very first work in the neural architecture search was did by Google. Again, they use thousands of GPUs that we probably for so many years with all our fundings. We believe we have very good amount of fundings. We got how many? 55? But their system easily got thousands of GPUs needed. But we will still be able to get to work on new technologies, new algorithms to reduce the computing power and increase the accuracies. So the work we did is to automated design architecture without trial and error of parameter tunings or thousands of times of parameter tunings. And actually, if I describe in a very simple way or straightforward way, is, for example, here is a deep neural network architecture. And it looks like you have a lot of blocks. It's like the kids playing Lego. But of course, if you generalize, you can imagine the search space is 1,000 times bigger. And then we design new techniques to explore the search space effectively and efficiently. So to show just some ideas, so we are using evolutionary computation algorithm to automate design of the deep learning models. And at the beginning, it could probably start with a small model, and it can later grow into a bigger model, and with a better performance. And at the end, it will give us, a brand new, not manually designed, do not need a lot of trial error or domain expertise designed network that help us to improve the classification performance, for example, on the image dataset. So this is what we have been doing. And last month, my plenary talk is about using evolution computation for design of deep neural network architectures. So, good. The deep neural networks give us promising performance on many, many different tasks. What is the limitations they have? For the deep learning models, the problem is it often have a huge architecture. In terms of architecture, we say it's many hundreds or even thousands of layers in the network. That leads to millions, hundreds of millions of parameters. Okay, for example, you give them a task to distinguish, to classify the image as a wolf or a dog. You pass the image to the huge neural network and they give you a label. However, you have no idea what did the neural network do, what did the deep model do, how that comes to give us a label as a wolf or a dog. Unfortunately, in many cases, it tells us something that's something even not misleading, but sometimes even wrong. For example, to distinguish these two images, if we go deeper to the model, sometimes we find it's the label of the wolf is more of the label of the background being the snow. If you take off the object of the wolf or the dog, but just give the background, it will still give you the label. So we have no idea. So how the neural network making this the decision? This is dangerous, right? So if we don't know how the decision were made, how can we trust the model? Especially on the very critical areas, for example, disease diagnosis or some other very important areas. So we can't trust those systems. So the idea is we need to explore explainable models. So following some of the work that we have been doing in our research group as well, so we're developing tree-based models. Okay, so with the tree-based model, instead of the network-based model, you will be able, or it's much easier, to follow the decision-making process. Here's the tree. You can looking at from the leaf nodes, like step by step, combine decisions, and come up with a final decision. We're also doing a lot of feature learning. For example, to select features, to select the most important features, let's say 5 features from hundreds or thousands of features. Those 5 are the most important features that affect your decision making. So they are the most critical causes for the problem. For example, here what we have for the human data set. For this data set, if you can imagine, it's a spreadsheet. So it has 7,129 columns. So each represents a feature. So each of them was provided to us and asked us to do a classification task. Tell us this row is belonging to two classes, one or AML, so represented by a blue and a red color. Out of this over 7,000 features, our model will be able to construct a very simple tree structure that can perfectly separate these two classes. But get rid of the features or the attributes of the columns that are not relevant to the task, we'll be able to focus on the most informative, most relevant information from the data. And we'll be able to follow how the tree makes decisions. It can as simple as just use a very simple arithmetic operators to combine them and to perfectly separate instances of different classes. But of course, this will be a relatively simple example. For a difficult task, we'll still need to have a very difficult, kind of a large tree to make a decision. But at least by selecting the most important features And by using the tree-based model, allow us to looking at how the decision was made from the leaf node to the parent node, the internal nodes, and up until the root nodes. We will be able, at least potentially, following the decision-making process to understand how the decisions were made. So that gives us the potential to do the explainable AI to build interpretable machine learning models. There's a lot of research we have been doing, we have done, and so under more recent years, instead of we were doing what we are good at, the AI research, and we're looking at what we are good for, or research are good for. So apparently, AI is helpful in everywhere. So we are using AI techniques every day, every minute. But where should AI do? What AI should be allowed to do? That's something that's not only about ethics. It can sometimes become a legal thing, right? It's about privacy and who is using the AI techniques. The more powerful the AI techniques, it actually can be more disruptive. And there are weapons using AI system to build. For the AI system used by the wrong person, the more powerful, the more dangerous it can be. What we need to do is to build a system that is bias-free, that accounts for human values, and that is transparent, accountable, and many other different factors we need to consider. And those systems should factor all those factors when in the decision-making process, especially in some morally significant situations. So that means that we need a lot of policies, regulations, and laws to regulate what we need to with artificial intelligence. And this has been another very hot topic recently, kind of researched by researchers from many different areas. So looking at what we have been doing here. So one of the examples given, so Jennifer also talked about the examples that we did in our research. So here we're also using the tree-based machine learning model to do skin cancer detection. Skin cancer is one of the top deadly cancer in the world. And for New Zealand, it's particularly not in the good situations, particularly that over 300 New Zealanders die because of the melanoma. So what we have done, so we built a tree-based model that can automatically detect and classify benign images or melanoma images. By feeding the images to the tree-based model, the system automatically learns this model. And more importantly, we will be able to see what features or what information are captured by this tree-based model. For this particular example, we're looking at there's one feature highlighted in pink, so there's feature 154. And if we're looking back to the data, we found this particular feature is capture the corner of the mole in the image. And this corner is one of the rules that's used by dermatologists in clinics. So that explains why our model using this feature to make this particular decision. And so that's something we have been working on, and we will be continue working on that. Some other regions called biomarker identification. So biomarkers are treated as how cancers release their secret. So it can appear in different forms. So also, we're using our techniques. For a particular example, for example, this is called the Apple Plus MZ dataset. It has 773 features. You can consider 773 columns in the spreadsheet. Okay. Among them, so 5 of them are labeled as biomarkers by the experts, by biologists. So that are the key we need to look for. And our algorithm will be able to find all of the 5. And also in the tree model structure, you'll be able to see them. So actually, our AI system is more creative. So not only find these 5 biomarkers, it finds something different as well. It finds some other combinations of features from the 733 features. They find another combination that also can achieve 100% accuracy for distinguish the instance of the different classes. So disease, for example, disease had cancer or no cancer. So that is particularly important because that tells us more about the problem domain, to give insights to the domain experts, and enable the deeper understanding of the problems. So that means that there are interaction between the features. Because of the interaction that we never thought of, so actually that can also tell us whether the person have a cancer or not. So this is another example we have been working on is the mussel farm. We have been working on the mussel farm, particularly we currently working on the mussel float void detection. So this is a very beautiful picture of the mussel farm, but in a bad weather, it's completely different. So with the wind, with storm day, the many farms lost many of these buoys. It would blow to everywhere in the beach. So our algorithms was to detect, without you sending a person in a very bad day to the sea, we use the camera there, and we're using algorithms sitting in the lab to automatically detect whether and how many of the buoys have lost. And we will be able to, after the day, we'll be able to send the workers to fix this problem. And our also task is those buoys are fixed when they first plant these mussels, when they're very, very little. And you can imagine with the growth of the mussels, it's becoming heavier, and the buoys become drawn down. And our system was to detect when and how many we need to add more mussel floats there. So that will significantly reduce the human labor and also of course, money involved. So this is another project we're working on, is for the fish industry. So we are kind of working this a lot with the Plant and Food Research, Crown Research Institute. So we work with the plant side and also the food side. With the plant side, we work with the team that we're using AI techniques to estimate the length of the fish without actually catching the fish. Based on the length of the fish and other data, we will automatically predict the weight of the fish, and monitoring the growth of the fish, and predict the health condition, and also estimate or plan the feedings for the fish. And after the fish was caught, so work with another group, kind of from food side of the Plant and Food Research Institute. We're working on the cyber marine project. That's to find a way to maximize the value of the fish. How much of the fish should go into the restaurant, how much of the fish to doing fish oils, and how much of them going to enzymes. So there are different ways that we're using the historical data to learn the model and to maximize their value. So those are all the New Zealand primary industries. Some are more that's closely related to us, Wellington trees identifications. Not sure how many of you know that actually in New Zealand, every 10 years, the New Zealand government will scan the tree of all trees in one city of New Zealand. The last time they scanned the city was Wellington. And we work with another Crown Research Institute last year with a joint project with Singapore we're working on identification of the Wellington trees. You see the tree on the street, each of them have a label, and they have the remote sensing images. We can find this in the database. Our task is to segment the different trees and to develop a system that can automatically identify the species of the trees. So in order to monitoring the trees in the whole Wellington region, and also probably generalize to other cities of New Zealand. So those are some examples that we're working on. So I will not be able to list all the work we have been doing. So we actually currently proposing the VUW Data Science and AI Center. So working with Professor Bing Xue, Abby Liu, and Richard, and myself, we have for the past years or more that we have with the support from the division and from the faculty. So we are developing this Data Science and AI Center. Our vision is to achieve research excellence and innovation and sustainable data science and AI. Our focus is to develop advanced fundamental research, innovative methods, techniques, but for key applications. Now, leading to the knowledge advancement with significant impact, economic, social, environmental, and health outcomes. Here we have 6 technology themes, which we have international reputation or leadership. And we have different application domains, most of them working on the primary industry and the important areas that closely related to our daily life, particularly for New Zealand. And we also work with Maori and the Pacific Aviation Masronga. We have a lot of planning around there, and we hope that we'll be able to show you more as a center in the near future. So we're not only doing research, we're not only doing publications, we're not only apply fundings, we also, as a group, doing as a lecturer, as an academic staff at the university. So we are not only doing our own research, we're also focusing on the educations. This year, we developed the New Zealand's very first and only undergraduate major in AI. So we start from next year. We were actually the very first one who developed the postgraduate majors in AI. That started in 2021 and has been going very successfully. Okay, so that's my talk. I would like to thank all the people I have been working with, my colleagues, my postdoc, and my students. In particularly, many of you know Professor Bing Xue. So the most important person in my career. He's probably also the most important person in many people's career. Last but not least, my family. The other 2 most important person in my life. My husband, Dr. Yiming Peng, he has the PhD in artificial intelligence. He's the best husband I can ever imagine. So when we first sit together, he said his goal is to support me become a professor. Now I achieved the goal. I achieved our goal. You probably should think about the next goal. All right, thanks everyone. This is the end of my talk. Thank you very much for listening.
Tanakuta katoa. My name is Ehsan Mesbahi. I'm the Pro-Vice-Chancellor for Wellington Faculties of Science, Health, Engineering, Architecture, and Design Innovation. And I'm delighted to give the vote of thanks to Professor Bing Xue for tonight's lecture. What I'm going to say now is not written in here. The subject of artificial intelligence is very close to my heart. And you can imagine how difficult for me is not to talk about it. I really enjoyed your presentation. It looked like from the time I started doing artificial intelligence, how much change has been there. When I started working artificial intelligence, I'm telling you, there was no computers around. So you can imagine what it looked like. Our university, Te Herenga Waka, is the world leader in the future-defining interdisciplinary field of artificial intelligence. Tonight, we have had just a glimpse into the cutting edge of artificial intelligence research that Professor Xue and her colleagues have been undertaking in the areas of machine learning, data mining, and image analysis. And she showed their efforts to solve a range of real-world problems. A very great example of not showing what you're good at, but what you're good for. Professor Xue has demonstrated just how far-reaching and transformative the outcomes of her research can be, advancing all aspects of our lives from healthcare, agriculture, aquaculture, and beyond. Her lecture reminds us of the important role of university in building the future of our society and our communities by providing the space to pursue knowledge and apply knowledge into different fields of science and technology. Professor Xue's sustained excellence and leadership in this field has significantly contributed to the university's international reputation in artificial intelligence and machine learning. One of Victoria University of Wellington's key strengths is preparing our students for the jobs and challenges of the future, and this is something that Professor Xue truly exemplifies. Her career has gone from strength to strength. Twice she has been awarded the prestigious Marsden Fund Grant, the hallmark of excellence for research in New Zealand. She was also the recipient of Victoria University Staff Excellence Awards in both 2017 and 2020, as noted by Acting Vice-Chancellor. As a passionate teacher, researcher, and director of our innovative artificial intelligence programs, she has been an invaluable asset to the School of Engineering and Computer Science and an exceptional role model for women in engineering. Bing, you're amazing. This is probably the most exciting part of my job, to stand here and then talk about my professors. It's my pleasure, and it's our university's pleasure, to congratulate you on the fantastic inaugural professorial lecture. And with this, I would like to invite everyone today here to join us in the common room outside for some refreshments. But first, before I leave you, I would like you to join me again to thank Professor Xue for such a fantastic presentation. Thank you.